live. So we're going to be graphing linear equations, and we're going to be investigating linear equations in the second unit. What's really important about this compared to past algebra classes that you had is that I will not let you use your graphing calculator. So if you've relied on your graphing calculator in the past, it's gone. Okay? Now, last unit, we talked about equations with one variable, like 3x minus 2 equals, 4. And we could solve this equation. I could add 2 to both sides and then divide by 3 or multiply by 1/3, and I get x is equal to 2. If we could plot that solution on a one-dimensional axis, this is 1D, one dimension, 1D, and I'd say, oh, x is 2. Boom. That's the only thing x can be 2. And we know that if we used a inequality symbol, say a greater than or equal to, that x could be values including 2 and greater than 2. This is a one-dimensional axis, okay? One line, one dimension. Now we have 2 lines. We have a two-dimensional axis. Not only do we have an axis for one set of variables, say our x's is typically our x-axis, we'll also be worrying about another variable, a y variable. And we will be plotting two-dimensional coordinates. Typically, these two-dimensional coordinates will be x's and y's, but they could be any other variables that we wanted. We just typically use x's and y's. Okay, now when I plot something like a 1, 3, that means on the x-axis, we are going to go to a x value of 1. On the y-axis, we would be going to the y value of 3, and here's the two-dimensional plotting of the point 1, 3. I could do something like 0, 5, which means on the x-axis, I'm at the x-coordinate of 0, but on the y-axis, I'm at the y-coordinate of 5, and this is a two-dimensional plotting of the coordinate 0, 5. We could also have, negatives for both of them, -1, -3. On the x-axis, I'm going to the left one. On the y-axis, I'm going to the negative coordinate of 3. I'm going down. Typically, y's, we go positive when we go up. We're negative when we go down. With the x-axis, to the right is positive. To the left is negative. And -1, -3 would be here. And that's the two-dimensional plot of that. On this two-dimensional axis, we have quadrants. We call this the first quadrant. We use a Roman numeral 1 for the first quadrant. This is our second quadrant. This would be our third quadrant, and this would be our fourth. Any line that's on the x-axis, we'd call being on the x-axis, not being in a quadrant. On the y-axis, on the y-axis. Okay? If I asked you which quadrant axis the following points are on, you should be able to do so. -3, 2. Recall this is our x-coordinate or our y-coordinate, going to the left and then up. This would be in the second quadrant. 4, -1, I'm going to the right and down. This would be in my fourth quadrant. 0, -2 would end up being right here on the y-axis. -1, -5 would end up being in the third quadrant. And 3, 0 means I'm going to the right 3, but I'm not going up or down at all. So this would be on the x-axis. Okay? Now, why we use a two-dimensional axis is when we are using two variables in an equation. Okay? If we have two variables, namely x's and y's, in an equation, the solutions will be a combination of an x and a y, not just x equals 3 or x equals 2, like what we had above, or y equals something. It has to be a combination. So take the two-variable equation 2x plus y is equal to 6. I can't just say x equals 3, because I'd have 3 plus y is equal to 6. If I use an x of 3, y must be 0 at the same time. And we'd say 3, 0 is a solution. It's an xy solution to my equation 2x plus y equals 6. I have to have both working together so that I have equality, so I have balance. If x is 2, I'd end up with 4 plus y is equal to 6. Well, then y has to be 2, which means 2, 2 is also a solution. I could have a solution like 1, 4. I could have a solution like negative 2, 10. All of these are possible solutions. But what's very, very important to know is that we are not limited to just whole numbers. You could use an x value of like 0.1. And if x is 0.1, your y value would be 5.8. That must go in to this equation so that we have 6 is equal to 6. And this is on, I'll move this up. And we could go on forever and ever and ever and ever with these xy solutions. For 2x plus y. We'd say there's an infinite amount of xy solutions to this equation, but typically all equations with two variables. Bless you. Okay? Now, if I asked you, hey, are the following points on the graph of this? What you're looking for, if you read this, is like, are the following solutions? The only way you can know if this is a point or a solution for 3x minus y equals 6 is just to try. You'd have to plug in this case, an x and a y. Plug in 2 for x. Plug in 0 for y. Make sure you get 6 equals 6. It is. 2, 0 works. 1, negative 2. Well, you just have to check. Now, be careful. We are subtracting a negative. I'm substituting in negative 2 for y. I still have minus y, so it'd be minus negative 2. This should turn into plus a positive. I have 3 plus 2, which just gives me 5. 5 does not equal 6, so no, this isn't a solution. It is not a point. 1/2 negative 9/2. 3 times 1/2 minus negative 9/2 is equal to 6. I have 3/2 plus 9/2 is equal to 6. I turn that minus a negative into plus a positive. We have a common denominator. I can add the two numerators to give me 12/2 is equal to 6, and this is true. 6 equals 6. So yes, that is a solution. Okay, and we could do the same thing for these. Why don't you guys do them quickly while I do them quickly, and then we'll just kind of check to see that our answers are the same. Sure. Okay, you guys are doing the next 3 while I'm doing them as well. some practice with our fractions here. If I have 2 times 13 over 4, I could decide to rewrite this as 2 times 1/4 times 13. And I could decide to multiply the 2 and the 1/4 together first to give me 1/2 or 2/4. So that ends up being 13 halves. So I have 1/2 plus, because a negative times a negative is a positive, 13 halves. I have a common denominator. I can add the numerators together, and yes. Okay. Now, we noticed and we talked about there being an infinite amount of solutions to this. Well, what we didn't do for 2x plus y equals 6 is actually look at what those solutions appear to look like when you're plotting them on a two-dimensional axis. Let's do it for these equations, okay? Let's graph by plotting points, but instead of points, I'll say point/solutions. Put your phone away, Mr. Manley. Use one of mine. Now, we want x-y pairs that work for y equals negative 2x plus 4. What's great is that if your two-variable equation is solved for y, solutions are easy. Pick an x, and you'll be able to figure out what the y is easily. So I could pick x's of like -2, -1, 0, 1, and 2. And plugging in those x values, we can easily get the y. -2 plugged in for x, that turns into 4 plus 4 is 8. And why don't we just go ahead and plot that solution on this two-dimensional axis. -2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, -2, 8. Okay? XY solution plotted on a two-dimensional axis. If I plug in -1, I get 6. So I could plot -1, 6. If I plugged in 0 for x, my y would end up being 4. 0, 4. Fantastic. If I plugged in 1, I would get 2. 1, 2. If I plug in 2, I would get 0. 2, 0. Okay? Now, everybody has instincts after they do this. What is everybody's instinct when you see these points that kind of line up nicely? Draw a line, right? You draw a line. Now, why do you draw a line? Because they connect, right? That's the obvious answer. It's got points. They look like they connect nicely. So why don't we connect them? What do you think, Mr. Barba?
Because you could have, well, no, you can have decimals in the middle.
That's a very good point. So I could plug in like 0.5, right? 0.5 or 1/2. And if I plug in 1/2 times -2, that's -1 plus 4, and I get 3. So we actually have the 0.53 right there. Could I plug in -1.5? Sure. And I'd get a solution. Guess where my solution would lie? Probably right here. Could I plug in 0.1 and get an xy solution using an x coordinate of 0.1? Sure, I plug in 0.1, it'd be -0.2 plus 4, that's -3. That's positive 3.8. So 0.1, 3.8. Let's write that one down. I can plot that point. That's a solution. How many more solutions could I plot? Infinite. Guess where all the solutions would lie? Right. So what's important to know is it's actually more and more solutions that we can plot if I look at more and more decimal values. Okay? All these dots are solutions. If I plugged in different decimals and I'd plot the xy pairs, they'd be plotted here. Now, let's keep going. If I continue to plug in more and more decimals and get XY solutions, I'd have more and more points that end up falling here.
And eventually make a line.
There you go. That's why we have a line. Why do we connect things? Because we are showing all of the possible dots, all of the possible XY solutions for this equation. So yes, we connect, but why? Because this line is actually comprised of an infinite amount of XY solutions for that equation. No way, right? Sometimes we don't realize, where does the line come from? It's solutions. They're XY points that work for the equation. The same can happen for this one. We have an equation solved for y, so we can just plug in x's. And I'm going to take my x value and square it. Now, it's important to know that if I take -2 and square it, -2 times -2, that's +4 plus 1, that's 5. -1 goes to 2. 0 goes to 1. 1 will give me 2. 2 will give me 5. So I could plot those points, -2, 5. -1, 2, 0, 1, 1, 2, 2, 5. Now we notice that these points don't end up on a line. It looks like we have some sort of U. Well, guess what? We can also plug in decimals. 0.1 squared is, I don't want to mess this up, it's 0.01. Okay, so if I plugged in 0.1, I'd get 1.01. Okay, so that's a point. -0.1, 1.01. If I found more and more solutions, I would plot their points, and guess what? They would create some sort of U shape. Okay, so would we connect them? Sure, but why? Because they are showing all of the possible XY solutions, the infinite amount of solutions for that equation. Okay, so that's where graphs come from. And go ahead and connect those lines. Don't just leave the dots. And go ahead and extend. You see I have arrows? Arrows mean that my solutions go on forever and ever and ever. I can plug in any x value, and I'd get a y that would associate with that x value with this equation. All right? But sometimes equations aren't nicely solved for y. Sometimes they're nicely solved for x. In this situation, x equals y squared, we could pick y's, and then the x's come easily. So I can pick a y of -2, -1, 0, 1, and 2. And if I square that value, I get the x, 4, 1, 0, 1, 4. And I can plot those points, which are solutions to this x equals this two-variable equation. 4, -2, 1, -1, 0, 0, 1, 1, 4, 2. We could look at decimals in between. I could plug in a value like -1.5 and get the x value. I could plug in a value like 0.9, -0.9, and get the x value. I can look at a bunch of other decimals, and I would find that the solutions could be plotted, and they would make another U, only this time it would be sideways. So yes, we would connect with a line, but what is the line? The line is representing all possible xy solutions to x equals y squared. All right? Now, some questions I could give you is, hey, if you have an x coordinate of 3, what would be the y coordinate of the graph of that? It's very simple. Just go ahead and substitute in the 3 for x and the b for y, so you can find b. If I have A5, what is A? Substitute A for X, 5 for Y. A for X. Solve. Now, we're at the point now where we don't have to show all of our steps. You guys have probably solved enough equations in your time so that you know that right now I would add 7 to both sides and I would get 12 equals 3A. You don't have to show plus 7 and plus 7 on both sides. We can do this. Okay? You now know that I would divide both sides by 3 to get 4 is equal to A. Don't have to show all the work to get there. Okay? You guys do the next 2. If you haven't done so already. Now we have 5 negative k, so it's important. This is x, this is y. X is 5. Make sure you plug in negative k. X is 5. Make sure you plug in negative k for y. Okay, because it's going to change things. If I distribute this negative, it'd be negative 2 times negative k. Well, that would turn into a positive 2k. Subtract 5, or add negative 5 from both sides. Divide by 2. Does that mean no solutions? No. 0 is a number. It has feelings too. All right. Well, we are going to not focus on U's or other interesting two-dimensional graphs that are formed by looking at all of our solutions for particular types of equations. We are going to focus on these lines, okay? The most general form of a line is having just an x and a y being multiplied by something equal to something else. Nothing fancy, there's no square roots, there's no squareds, there's no other types of functions, just an ax plus a by is equal to a c. This is the most simple part of a line. Now what's great about lines is that lines increase and decrease consistently, or decrease consistently. And lines typically always have intercepts. Typically a line will cross through the x-axis and the y-axis once at some location. We call this point where it crosses the y-axis the Y-intercept, Y-I-N-T for short. This point where it crosses the x-axis, the x-intercept. What's important about all y-intercepts and x-intercepts is their characteristics. An x-intercept always has what type of coordinate?
0 for the y.
Yes. Y will always be 0 no matter what type of line we have and no matter where our x-intercept is located. Y will always be 0. So this point here, y is also 0. For our y-intercepts, x is always 0. So it doesn't matter where our line is drawn when it crosses the y-axis, the x is always 0. You can find intercepts easily. Whenever you're asked to find an x-intercept, just plug in 0 for y. See which x value goes with that y of 0. Whenever you're asked to find a y-intercept, just plug in 0 for x. Figure out which y goes with a 0 for x. So here my y-intercept would be our x-intercept when y is 0. I would have 3x plus 2 times 0 is equal to 9. Well, 2 times 0 is 0. 3x plus 0 is just 3x. I actually can just almost forget about the 2y and just have 3x equals 9. That gives me x equals 3. It's very important to list off that it's the solution 3, 0. That is the point at which this graph of this line crosses all the way away, off your desk. Crosses the x-axis. Okay? Y-intercept when x is 0. I would start by plugging in 0 for x. But I notice that 1/2 times 0 is 0. It goes away. I just have 2y is equal to 8. That gives me y equals 4. It's important to realize that it's the solution 0, 4, the ordered pair. Not just x equals, not just y equals, but both 0 and 4. That is the solution to 1/2 x plus 2y equals 8. This is the point that you would plot. So if you just stopped with this, here, I want you to understand that this means nothing without its buddy, its other half. Just one value means nothing for a two-variable equation without its other half. Okay? Go ahead and find the other two, and then we'll move on.
When do we get out of here?
Not yet. Fantastic. Well, we are not going to be using graphing calculators to graph these lines, okay? So we need other techniques to easily graph lines. Well, if we have an equation in this form, we call this a standard form, where we have an ax plus a by equals a c. An easy way to graph the equation, knowing that all of my solutions are going to fall on a line, is to find the x and the y-intercepts. Go ahead and find out what our y is when x is 0. And find out what our x is when y is 0. If I plug in 0 for x, my y would be 3. If I plug in 0 for y, my x would be 4. Giving me 2 points, 0, 3. Make sure you understand the x and the y. 4, 0. Boom. Connect and extend. Why? Because these are where all of the xy solutions would fall. And these are really a plot of all of the xy solutions. Okay, so we have a general understanding of what my x, comma, y coordinate solutions, where they would be along this line of solutions. Okay, we can do it for all of the others. If x is 0, y is 10. So let's say we're up here. If y is 0, x is -5. That'd be over here. And boom. Knowing 2 points is all you need to graph all of the solutions to a linear equation. because you know all of your solutions. If I looked at this point here, it'd be a solution. This point here would be a solution. This point here would be a solution anywhere. Okay, go ahead and plot the other two while we're still here. Okay, having just 2 points shows us the direction of all of our solutions, shows where all of our solutions would be. All right, now we can have horizontal and vertical lines. If I have an x equals a number, let's say 3. Well, typically we'd say, oh, you would just plot this on a one-dimensional axis. And you'd be correct. Plotting this on a one-dimensional axis would be totally fine. Okay, because it's just one variable. But let's say, just for certain situations where we would like to graph this on a two-dimensional axis, how would we graph this point if we're on 2 dimensions? Well, it's important when x is 3, y could be anything. So you're thinking about x coordinates of 3, y could be 0, y could be 5, y could be -2. If I started plotting those points, I would find that a x equals one variable equation would end up being a vertical line. Now, let's say I have y equals 3. Again, you could say, all right, well, y is equal to 3. There you go. One dimension. That's easy. But let's say if we wanted to graph on a two-dimensional axis, it can be useful. It will be useful in certain situations. We know that x can be anything. So as long as my y-coordinate of my solution is 3, I can use any x-coordinate, like 0, like 5, like -2, like any decimal, and you'd have 0, 3, 5, 3, -2, 3, and if you continue to plot all those possible solutions, we'd see that we'd end up having a horizontal line. Okay, some people still mistake which one is which. This is horizontal, and this is vertical. Okay. So some questions that could be asked are: write an equation for a horizontal line passing through the point 2, 3. Well, 1, 2, 1, 2, 3. Here's that point. Horizontal is the flat line. So what is consistent about this line and all the points on this line? The y-coordinates are 3. So that would be a y equals 3 equation. Write the equation for a vertical line passing through the point -1, 4. Well, if you have the point -1, 4, and I want a vertical line, that's the straight up and down line, what is consistent about all of these points on this vertical line? The x-coordinate is always -1. All right? Now, lines are great because lines have what we call a slope. It is the rate at which the y's are increasing or decreasing consistently. You've talked about slope many times before as being the rise over the run. This ratio provides our amount risen per 1x, either going up or going down. We could say it's the change in our y values of our line over the change in our x values. That triangle is the mathematical symbol for change. And to find some change, you can just subtract two y coordinates together from two different points and subtract two x coordinates together. Take this line. If this was an x-intercept at -2 and a y-intercept at 1, the graph would be going up 1 and to the right 2, or you could consider it going down 1, which would be a negative direction, and to the left 2. Okay, so the rise over the run using this way would be 1/2. If you thought of these as points, this is the point -2, 0, and this is the point 0, 1. You could also, as long as you are consistent, say this is our x1, y1, and this is our x2, y2. We can use this formula, subtract the y coordinates from each other, 0 minus 1 over -2 minus 0, and we'd get the same slope. Okay?
Is slope n?
Yes, we'll get to the notation that we use for slope when we get to the equation. Get 7 minutes. Find the slope of this line. This would be a rise of 3, up 3. I'm going to the right 2. Since I'm going up, that's a positive y direction. Since I'm going to the right, that is a positive x direction. We'd say the slope is 3/2. If I have points, you can consider one of these x1, y1, the other one x2, y2. As long as you are consistent, subtract your y's, subtract your x's. If we have subtracting a negative, change it to plus a positive or plus a negative. If you're just subtracting, that might help you. This is -2 over -4, which is 1/2. What is the slope of a vertical or a horizontal line? Well, a vertical line has rise, but no run. So it's some sort of rise over 0. We are not allowed to divide by 0. It is not allowed. It doesn't make sense. How many times does 0 go into 5? It can never be done. So we consider this undefined. However, for a horizontal line, we don't have any rise, but we do have run. Well, 0 divided by anything is 0.
Could you say the slope is perfectly vertical?
I'm going to use the mathematical definition of slope, which is the change in our y's over the change in x's, and I'm going to say it doesn't have slope. But yes, I would like that explanation probably better. If we go through the work on this, we get -4. 1 minus -3 over -3 minus -2. Give us -4. Okay. Alternate forms of equations. Well, if you solve for y, turns out we get linear equations in this form, y equals mx plus b. Now, if I plugged in 0 for x, I'd get my y-intercept, right? Well, if I plug in 0 for x, this goes away, I get y equals b. This is why b is what we consider our y-intercept. M will be the rate at which the y's change for every x. Well, multiplying some value by x will change the y's. This is why this value before x ends up being our slope. We also can have an equation in this form. This is called point-slope form. This is slope-intercept. Y minus y1 equals m times x minus x1. It's important when you're using this that this stays. Don't change y and x. Leave it alone. M is my slope, and x1, y1 comes from a point that I know. All right. Write an equation for a line with a slope of 3 and a y-intercept of 2. That's easy. I can use slope-intercept. Write an equation of a line with a slope 1/2 containing the point 2,4. I can use point-slope. Let's just write it down again. Y minus y1 equals m times x minus x1. Actually comes from the slope formula, this equation. Leave the y. y1 comes from the point. M comes from my slope. X1 comes from my point. You can leave it like this. You're asked for an equation of a line. This is an equation of a line. Lines don't always have to be in y equals form. If I'm asking you for an equation, boom, you're done. If I ask you for an equation in slope-intercept form, then we'd have to solve for y. Write an equation with an x-intercept of 2 and a y-intercept of 6. Well, I want to do y equals mx plus b. But the problem is, I'm not given m. I just have the b. But I can find the m, find the slope, either by graphing and using rise over run, x-intercept of 2, y-intercept of 6. Understanding I'm going down 6 and over 2, down 6 to the right 2, that would be negative 3. Or knowing that we have the points 2, 0, and 0, 6, we can use the formula for a slope to get negative 3. Write an equation of a line passing through the points 2, 3, and 6, negative 2. Well, we want to use point slope. It doesn't matter which point you use. Say you want to use 2, 3. The only problem is I need m. Use the slope formula to find m. Boom. That's an equation of a line. You do not have to solve for y unless you are asked to place things into slope-intercept form. However, solving for y does help us find information about a graph very, very quickly and easily. Solving linear equations for y puts your equation in the form y equals mx plus b, and just by visual inspection, you can both find the slope and you can find the y-intercept. Now, it's very important to practice solving for y. I'd like to isolate the y. I have negative 2y equals negative 4x plus 9. Then I would divide both sides by negative 2. Now, it's important when you're dividing by negative 2. It's the same as if you multiplied by negative 1/2. Now, when I multiply by negative 1/2, it's obvious to see that I would distribute. That way, you know that this becomes that and that. I'm going to finish the notes right now. If you want to keep watching, extra practice problems we'll practice, and we will have a quiz next class on Tuesday when I see you. Enjoy your long weekend. I love you all. You guys are great. Mm-hmm.